The goal of this video is to see a demonstration for the activity that is part of Lab Activity 1. If you open the lab activity in the Dropbox, question 5 is asking you to do a sampling activity that requires you to use a random number generator along with an Excel file that is both in the datasets folder as well as in the lab activity category. The demonstration for this assignment has a sheet that goes along with it in Topic 3 material. This sheet is the sampling activity instructions. The goal of this activity is to investigate what it means for there to be variation between samples, as well as to understand what it means for a sample to be representative of a population. The second bullet is a really important concept in statistics, but it's very hard to understand without getting an actual visualization of it. Down here there is an example of a perfect representative sample. So in an ideal situation, every single member of the population would be known, but of course this isn't always even possible. No less is it possible to actually talk to everybody in your population. So this is why we need a sample. In this situation that's listed, if we did have the population, we wouldn't need to perform a sample unless we wanted to gather information besides the purple, pink, green, whatever that stands for. So in the population, there are 500 people that are purple, 1,000 pink, and 1,500 green, which is a total of 3,000. 500 out of 3,000 is going to give us 0.1666 repeating. And to make that into a percentage, we have 16.67%. So the population has 16.67% of whatever this characteristic is in purple. For pink, the population has 1,000 out of 3,000, which will be 1/3. So that'll be 33.3 repeating. And then green will be 1,500 out of the total, which is 3,000, which is 50%. In order for the sample to be perfectly representative of this population, the percentages that we get when we randomly select these 60 individuals, so 30, 20, and 10 is 60, would be the same exact percentages as what the population would have. This isn't a perfect world, of course. However, it is pretty impressive how often we can get results that are very, very similar to the population without having that large of a sample size. There are formal ways that we will be calculating sample size. However, the idea now is to just understand how samples vary, as well as what it means for a sample to be representative. So if we check our bottom box, our sample, we get 16.6 repeating, or 16.67 for the purple. We get 20 out of 60, which would again be 1/3. So 33.3 repeating percent has pink. And then 30 out of 60, it would again be 50%. So this is an example of a perfect representative sample. Again, however, in the real world, we don't know everybody that's in our population. We don't have a list of every single person in the United States or every single iPhone that has a cracked screen. So this is the reason why this is so amazing, because we can perform a pretty small sample from our population and still obtain results that are almost identical to the population if they are selected properly. Another bone to throw in here is that a lot of times you aren't only interested in one variable. So we talk about Casper College students a lot, and one thing that you can think about that they all have in common or different are whether they're full-time or part-time, whether they are traditional or non-traditional students. They can be different majors, they can have children, they can work full-time or part-time. So there's a lot of different characteristics that we usually have when we're looking at members of a population. So ideally, we have a few variables that we are collecting on. However, sometimes it does get more complicated than that. In this activity, we are going to be using, and we're obviously not going to be working in groups, we're going to be using the Excel file that is located in the datasets folder. Whoops, we don't need my email. So we need the datasets folder. And right now we only have the sampling activity data. There will be more files in here as we need them. In addition to this, you are also going to need to go onto the website random.org. And this is a website that generates random numbers between 1 and whatever ending number that you specify. So the goal of this is to create a random sample of size 20 from our population, which is an Excel spreadsheet that has 720 people. So we end with Carrie Zimmerman. Their gender, age, and their political party that they are registered for. This is a made-up data set, but it is modeled off from one of the states. I believe it was Iowa. So what we're going to do here is we are going to set up our random number generator to be from 1 to 720, and we're going to hit generate, and it is going to give us a random number. And so then you want to use your file to scroll to the number 14, in this case, if you got a different number, which I'm sure that you probably did. 14, the only thing that we need to record here is the person's political party. So I'm going to go over to my very high technology notepad over here, and let's see, number 14, Hannah Andrews, Democrats. So I'm just going to make a tick mark here, and so this would be much easier to do on a piece of paper. But so I have a tick mark that represents Hannah Andrews' political party, and then I'm going to generate another random number. My next random number is 394. I recommend using the scroll bar here. You might have to enable editing in order to get complete access to that scroll bar. So I'm going to scroll down until I get to 394. And this is Kayla McCarthy, who is registered as a Republican. So now I'm going to continue this process until I have 20 randomly generated numbers and the political parties that go along with them. I'm going to pause the video and pick it back up when I get to the end of that process. So here I am at the 20th number. So now I'm going to figure out the percentage of each political party that I found using my random number generator. So the total number that we have here is 20. So when we are trying to figure out the percentage of each political party, it's part over whole. So it's going to be 5, 6, 7, 8, 9 out of 20, which is going to be 45% for Republicans. And since we have the same count, we're going to have the same percentage for Democrats. And so then we have 2 out of 20, which will be 10%. So since we do know every single member of our population, we can actually tally up the number of Democrats, Republicans, and Independents. So we again would not have to do a sample if we had this information already. So before I do my grand reveal of the true percentages, I would like to think about what I think all of these percentages would be if I found out the entire data set. So it looks like I would say Democrats and Republicans are definitely larger percentages if I'm just speculating on the population. Definitely a smaller amount of independents. And again, Democrats and Republicans are pretty similar. So at the top of mine here, I have the percentages of the three political parties if you count every single one of these. So we do have that Republicans and Democrats are pretty, they're larger percentages. However, in this population, Democrats really do come out as a majority, which we don't see reflected here. Independence is a smaller percentage, which is pretty consistent with what we found. However, you have to imagine that if we didn't have this at all, we can't go out and talk to 75 people or 720 people. We can, however, use a way to randomly select them and just get a smaller selection. If we had a bigger sample size and it bigger and bigger and bigger, eventually we'd reach the entire population and our percentages would be exact. So my question is do you think this sample size of 20 was good enough, or should we have probably had more, just on, your feeling? Definitely think that we should have more in this case, and that's what you are going to investigate in your lab activity. If you have any questions in the lab activity, please feel free to email me. This video should definitely help. You do need to generate your own new random numbers and find your own first 20 sample.